Hi, so on these couple slides, we're going to talk about when is something a chemical reaction, when is it not a chemical reaction, and how can you kind of tell. So starting up here, I've got a chemical reaction kind of drawn out up here. And we can see this chemical reaction where we're taking this substance here, which is substance A. It's got it's two atoms joined together here, and we're showing them symbolized as like gray circles. And then here's substance B, two red circles joined together. We're going to take these two substances, we're going to join them, mix them together. That's what this plus symbol is showing. And then there's going to be a change. And that's what the arrow is telling us. Something is happening to take the stuff on the left and turn it into the stuff on the right. And if we look on the right, these substances that we're seeing here are fundamentally different. This is different to this or this. On the left, we got white stuck to white and red stuck to red. And on the left, we have white stuck to white and red stuck to red. On the right, we have red stuck to two whites and red stuck to two whites. So the atoms have been rearranged and joined together in a different pattern than they were to start with. And that's what it takes for there to be a chemical reaction. The atoms actually have to be rearranged and joined together in a different arrangement. So if, for example, this hadn't happened, if this wasn't here and this wasn't here, but instead on the right side, I just had red stuck to red again, and I don't know, I had to draw white, but let's say like white stuck to white, that wouldn't be a chemical reaction because this hasn't changed. It's here and it's the same here. And this hasn't changed. It's here and it's the same here. That would not be a chemical reaction. But we do have a chemical reaction shown here because we've rearranged the atoms and now they're stuck together in a different formation to make something different. So this is a chemical reaction. And the things that in a chemical reaction, the stuff that you start with, these are called the reactants. Reactant. All right, both of these are reactants. This is a reactant and this is a reactant. The thing that takes part in the reaction. And the stuff that you get out at the end, which is on this side, these are the products, what you produce. All right, so these are our reactants, what we start with on the left, and these are the products, what we end up with on the right. And the arrow shows you that you're going from reactants to products. The arrow symbolizes that there's a change going on. So this is some vocabulary. Reactants turn into products. Okay, now how we write examples in chemistry and biology, there's many different ways that we can symbolize substances, molecules usually. We can use letters, so we can use shapes, we can use words, and we can use formulae, all these things. But basically, we always use an arrow to indicate when we're changing from one thing to another thing. So for example, we could say A turns into B. In this example, A would be my reactant and B would be my product. I could also say X turns into W plus Z. In this one, X is my reactant, W plus Z are my products. So in this case, I'm breaking X down into two things, so I have one reactant, two products. We can do that. Or I could say R plus S makes T. In this case, these are my reactants, two reactants that I'm joining together to make one product, T. So it doesn't matter how many things you have on either side. I could have A plus B plus C plus D makes E. These would be the reactants and there would be one product. So you can use letters to symbolize things just like that. You can use shapes and colors like I did on the previous slide, the circles, the red and the white circles. You could have words. You could write hydrogen plus oxygen goes to water. Or you can use formulae. So this is what we had on the other slide. Hydrogen plus oxygen goes to water. that's using formulae. Many different ways of symbolizing reactions. Also, there's a couple things to be aware of, that you don't always have to write reactions from left to right. We tend to do that because we read English, and English always runs left to right. So I tend to write, A plus B goes to C, right? And this is my reactants, and this is my product. But I could just as easily go A plus B makes C. I could go down the board. That wouldn't be wrong. I could even say, lost my pen a second. I could do, I don't know. I could go this way if I was feeling really adventurous, and I could say X plus Y goes to Z. So in this one, these would be my reactants, and this would be my product, because the arrow really tells me what's happening. It's telling me I'm starting here and I'm going into this one. This is what I'm making. The arrow points to the product. So I start with X and Y and I'm turning it into W. You've got to look at the direction of the arrow and what it's telling you, what's turning into what. It might not necessarily go left to right like an English sentence would go. Sometimes even we have cycles in biology. We have A turning into B, which turns into C, which turns into D, which can be turned back into A. So in this example, A is a reactant and B is a product. So this is a reactant, and then this is a product of this first reaction, this arrow here. But if we look at the next reaction, I'm going to change color. Here's B turning into C. In this example, now B is now a reactant because it's what you're starting with, and you're turning it into C, which is now the product. So depending on what you're looking at, here B can be a product if we're looking at the first reaction, or it could be a reactant if we're looking at the second reaction. And this is an example of kind of cycle. We get these a lot in biology. Last but not least, you don't have to use letters. I could do triangle plus square turns into funky shape like this, right? So I'm using shapes here to symbolize molecules. Again, these would be my reactants. This pen is kind of funky. And this would be my product. So you're going to have to get used to seeing all these different ways of showing chemical reactions. Sometimes I might use colors, sometimes I might use shapes, sometimes I might use letters, sometimes it'll be words. You always look at the arrow. The arrow tells you what you're starting with, the reactants, and what you end up with, the products. So just a quick, simple review of how we show reactions in chemistry and biology.